Okay, so today we're going to have a look at how to calculate the area of a parallelogram in 3D space. So let's get straight into it. The area of a parallelogram with sides A and B is equal to the length of the cross product of those two sides. So what does that actually look like? So a parallelogram has parallel opposite sides. Okay, so it kind of looks like a leaning rectangle. So if we've got a parallelogram with sides A and B, you can see we do here. We need to take the cross product and work out the distance of that vector, and that will give us the area. So we've got our parallelogram here. It's got sides A, B, C, and D, and we've got the coordinates of each, and we're just going to put those in there. I'm going to call this A down here. So we're going to call that -1, 2, 3. We're going to call this up the top B. So this is A, B at the top, and that's 2, 1, 4. And we'll call this one over here C, which is 0, 1, 0, 5, 1. The first thing we'll have to do is work out the length of each of these vectors. So vector A will be equal to, we're starting here and we're finishing over here. So you take the coordinates of B, so 2, and you subtract the starting position. 2 take 1, 1 take 2, and 4 minus 3. All right, so that is equal to, so it's 2 minus -1, so 2 plus 1. So it's going to be 3, -1, and 1. And for B, it's going to be 0 minus -1, 5 minus 2, and 1 minus 3. So I'm just taking the second quarter and minusing or subtracting the first. So it's going to be 1, 3, and -2. So the next thing we'll have to do is work out A cross B. So we're going to do that by setting up the table. So I, J, K. And then we go straight across to 3, -1, and 1. And 1, 3, -2. And we've previously seen a couple of ways to work this out. But I'll just write quickly the first way. So you put in I and the determinant of -1, 1, 3, -2. So that's supposed to be an I, minus J and the determinant of, we change the side, so 1, -2, 3, 1, plus K lots of 3, 1, -1, 3. Okay, so we've looked at the formula of this before. You can also use a calculator, and that's what I'm going to do now. So what we get is this, -1i plus 7j plus 10k. Another way we can write that is in our more standard vector form. So it's going to be -1, 7, and 10. All right, but to work out the actual vector, to work out the actual area of the parallelogram, we have to work out the length of this vector. So I'm going to call this vector D for no reason. I'm just going to label it like that. So the length of vector D is going to equal the square root of the first term squared, -1 squared, plus second term squared, 7 squared, plus 10 squared, which equals 1, square root of 1, plus 49, plus 100, which equals the square root of 150. All right, I'm going to leave it like that. You could also write units squared because it is an area. We didn't know if it was meters or centimeters or millimeters or anything, so we're just going to write units squared. And yeah, that's it. That's how we work out the area of a parallelogram. Thank you.